Now, let's see certain character vectors and let's create character vectors with the help of our one R program. So character vectors contain alphanumeric values and special characters. So if I have alphanumeric values like A1, B7, any code or PAN card number, that is alphanumeric value where there is alphabet and also a number. And special characters like some symbols. Here in this example, I see V1, which is my vector, and it is assigned a list of values geeks, 2, hello, 57. So you can see over here that geeks is my character value. 2 is automatically my character value, which is enclosed in the single quotes. Hello is also a character value, but 57 was a number, but it has been implicitly coerced into character data type, or you can say automatically it has been converted into character data type. So now, displaying type of vector, I apply the command type of v1 and I see the output character. So I can see that the moment I see the output of v1, all has been converted into character data type and all the values will be treated as character data types. So though the data is of different types or different origin, but they have been coerced as per the coercion rule, they have been casted into the a data type which overrides the rest of the data types. So in this case, character data type overrides the numeric data type. Now, logical vectors contain Boolean values such as true, false, and NA for null values. So the logical value vectors will have either true or false or NA, not applicable. So displaying the type of vector over here, if I see type of v1, I see the value is logical. Now let's understand creating a vector in 3 different ways. The first one we are using again and again throughout this session, and we have seen the C function, which is called as the combine function, and it combines the values as a vector. So by default, the type will be double. So you can see over here, I have written C within brackets 61, 4, 21, 67, 89 and 2. So this is the list of double values, and this list of values is assigned to a variable x. And now you can see I'm using the cat function. I'm printing using C function, which is the caption that I'm displaying the output using C function and then followed by the value of x. So you can see that the x is replaced with the list of values, which is 61, 4, 21, 67, 89 and 2. And then a new line, which means come to the next line. Now in the second way, we have a very special function which is called as the sequence function. This sequence function is displayed by written by SEQ and brackets. So SEQ bracket function is used for creating a sequence of continuous values. As the word suggests, sequence. So it is a sequence of continuous values. So you can see there is a very typical length.out attribute. This length.out attributes define the length of the vector. So here let's consider the next line, which is y equals to sequence 1, 10. You can see over here y is my variable which will be capturing the values generated through sequence. The lower limit is 1, the upper limit is 10, and the length of the output is equal to 5, which means I want 5 numbers to be generated within the range of 1 to 10. So now when I print the output using sequence function and print y, what is the result? You can see over here the output is 1, 3.25, 5.5, 7.75 and 10. So you can see the values are coming over here, and these values are basically 5 random numbers which are generated from 1 to 10, and sequence automatically from 1 to 10 the median is 5.5 because 5 and 6 are the middle points, that is average, so we get 5.5. Then from 1 and 5.5 the middle value is 3.25, and from 5.5 and 10 the third we can call it quartile is 7.75. So that is how I'm getting the values. The third way of creating a vector is again a very simple way, and we just use the colon operator. It is a very simple way of creating a vector. I have taken a variable z and equating that to 2:7. So this means I'm creating a vector, and I'm creating a vector with the help of colon operator. So all the numbers from 2 to 7 will be generated in my vector. So using the colon operator, I'm creating my vector and all the numbers from 2 to 7. So you can see over here the output using colon. I'm getting all the numbers from 2, 3, 4, 5, 6, 7. We can see the difference over here between the sequence and the colon operator. You can see here that in the sequence, I have given the lower limit and the upper limit, and I had the opportunity to decide the number of values I want in my vector. But when it comes to colon operator, I can only give the lower limit and the upper limit, and all the numbers within that range will be printed on the screen. So that is the difference between the two. How to access the elements in a vector, and that is the process of performing operation on an individual element of a vector. So basically I have a vector, I have list of values, but how to access the element in a vector? So the first way of doing it is using a square brackets. By accessing the element with an index number, now in this example, you can see that x is equal to c and within brackets 2, 5, 18, 1, 12, where you can see 5 values. Okay. And then I use the cat function, and using the subscript operator, I write x square brackets 2. So now square brackets 2 means it will pull the value from the second index of the vector. So the second value in this index is, in this particular list of vector, is 5. So you can see the output that using subscript operator we have 5. So with the help of subscript, explicitly I'm fetching the second position. The second position is 5, and automatically the output is also 5. So that is how I can operate on individual elements. Now second one is by passing a range of values inside the vector index. So basically inside the vector index I am passing a range of values. So here you can see y is my vector where I have 4, 8, 2, 1 and 17. So using the combine function I have created the particular vector, and now here I am writing yc is equal to 4, 1. So you can see by using the range of values in the vector index, we can say 4, 1. So this is the range of values. So I get the output as 1 and 4. Likewise, logical expression. So in the logical expression, what I'm doing, I have a vector which I have created with the help of a C function. And now this C function is assigned to Z, which is my variable. And when I'm concatenating or I'm printing on the screen using logical indexing, I'm writing Z, and within brackets Z is greater than 4, which means whichever element is greater than 4 will be displayed in the output. So you can see over here that in the vector there is 5 and 5 is greater than 4. So the output is 5. Likewise, I have put a logical condition. So whichever element is meeting the criteria will be displayed on the screen, and whichever element is not able to meet this condition, which is Z greater than 4, will be suppressed in the output. So you can see the output over here. It is 5. So using logical expression is quite a simple task, and very easily we can apply a little filter within the square brackets for a particular vector and bring the values which we want to see. So you can consider logical expression as a little filter which I have applied on my vector. List. Now let's understand the concept of list and how we can work on it. A list is an R object which contains many different types of elements inside, like vector, functions, and even another list. So basically, list is a very robust R object, and within a list, I can have a vector, a complete vector. I can have a function, and I can even have a list inside it. Let's have a look of this example and understand. List 1 is my variable, and list 1 is created with list function. You can see list function over there. Within the brackets, I have passed a vector 2, 5, 3 with the C function, which is the combine function. Then comma 21.3 is another data type, which is the double data type. And then sign. Sign is what? Sign is a function. So there are 3 different data types inside a list. So that is the beauty of list, that in the list I can have multiple data types stored in a list and I can access the values. Likewise, if I'm printing the list, how will I print? Very simple. I write print. Within the parenthesis, I write list1 and you can see the results. So the elements, each elements are printed. First element is what? 253. Second element is what? 21.3. And the third element is what? Function x dot primitive sign. So that is the function. Another very interesting R object is matrices. We have a separate lecture on matrices, but here I'm just teaching you the concept of matrices. So a matrix is a two-dimensional rectangular data set, something which is in the form of rows and columns. It can be created using a vector input to the matrix function. So basically how I create a matrix is a question mark. Let's have a look on the code. First, I'm creating a matrix. So there I have written M. M is my variable which is holding a matrix, equal to matrix, which is a function I'm calling. Within brackets, I have passed the values with the help of C function, which is the combine function. The values are A, B, C, B, A. N rows equals to 2, which means number of row equals to 2. Number of column equals to 3. And by row equals to true, which means I have to fill this list of values, the vector row by row. So you can see the result over here. The result is AAB, and in the next row it is CBA. So you can see if by row is true, row by row the values will be filled, and if by row is false, column by column the values will be filled into the matrix of given number of rows and given number of sizes. Now, how to print this matrix? As you can see, this is just single line command, print, and within brackets I'm writing M, which means I write print M and press enter and I get the complete matrix on the screen, where you can see that there are 3 columns and there are 2 rows. You can see 1, 2, 3 are the 3 columns and 1, 2 are the 2 rows, and that is how the matrix has been created. The data type of the matrix is character data type. Matrices is just one grid of rows and columns. Now arrays is what? Arrays, just imagine of a matrix. If I want to have a stack of lot of matrices, I can do this very easily with the help of arrays. So while matrices are confined to 2 dimensions, arrays can have any number of dimensions. The array function takes a dim attribute, dim for dimension, which creates the required number of dimensions. That is 1 dimension, 2 dimension or 3 dimension. So in this example, you can see I have created an array with the array function. The name of the array is A over here. Again, with the C vector, I have created green, yellow, 2 keywords, and the dimension is again created with a C function 3, 3, 2, which means 2 matrices of size 3 by 3. So the first is row, second is column, and the third is number of matrices. So you can see over here 3 by 3 by 2, and then I write print A. A is what? A is my array. So I'm just printing A and I get the matrices, and you can see the values automatically filled by putting green, yellow in an alternative manner. Now you will ask, where is the need of such kind of data? Just think of a scenario that there are 4 quarters of a sale and there are 3 salesmen. So I want to know that there are 4 quarters and 3 salesmen and there are 4 zones. So for the first quarter, I have 4 zones, east, west, north, south, and 3 salesmen. So that matrix of salesmen versus zones is my matrix, but that is only for the first quarter. Now I want to repeat the same information, or I want to see the information for the second quarter, then that would be my second matrix. And likewise for the third quarter, that is from July, August, September, and then for the fourth quarter, which is October, November, December. So sometimes the information is such that it goes quarter by quarter or month by month. Or let's take example of attendance. If there are 30 days and there are 60 students, so there is a grid of attendance of 30 days and 60 students. But this is only for a month of January. Same thing is repeated for the month of February and March and April. So in that case, the third dimension would be 12 because there are 12 months. So that is how, with the help of arrays, we can always have extra dimensions to a matrix, or we can say we can stack multiple matrices with the help of array.